So actually we are looking for that measure. This is under the demand. The difference between consumer's reservation price and ordinary demand curve, is due to income effects. And that's how I started the class. But if the consumers, again, what is the income effect? If I buy unit by unit, every time I have less income. So now I have to look on a new demand function, taking into account that my income went down. So this has an effect of my willing to pay to buy more units. So my willingness to pay becomes smaller. And that's the income effect. We ignore it and we say, forget about income effect, not income effect. We measure it by the area under the demand function. But if the consumer's utility function is quasi-linear in income, then there are no income effects, because the amount that I'll buy from each one of the goods, each one of the commodities, beside the commodity which is money, because what is a quasi-linear, you can think of it as one of the goods is money, and the price of money is 1. In that case, as I demonstrated to you before, my demand does not depend on my income. It depends only on the price. Okay? So, but the demand for the goods other than the money. But if the consumer utility function is quasi-linear in income, then there are no income effects, and consumer surplus is an exact measure of gains to trade. So then I have no problem, and sequential or not sequential is exactly the same. The consumer's utility function in quasi-linear in x2 is this. What is it? The utility from x1 and x2 is some function of x1 plus x2. Take P2 equals 1. Why? Because the price of money of $1 is $1. Then the consumer's choice problem is to maximize this utility subject to budget constraint. But x2 is m minus p1 x1. So I can invert x1 and put here m minus p1 x1. Or, in order to maximize, I can say that the marginal utility from x1 is the derivative v prime of x1 divided by the marginal utility of x2, which is 1. So the ratio is v prime, equals p1 over 1. Because the price of 2 is 1. So I'm getting that the demand is V prime x1 equals P1. Give me P1, I tell you what is the x1. Give me x1, I can tell you, but there is no M in it. Nothing. And that's why that doesn't have income effect. But let's look it. Okay, so I put the x2. I have the utility now with, instead of x2, I'm putting M minus Px1. So this is U, the utility. Okay. Utility is V plus Vx1 plus x2. x2 is m minus p1 x1. So the utility is Vx1 plus m minus px1. This is the utility. Now, in order to maximize utility, I take the derivative, V prime. This is 0 minus the derivative of p1 x1 with respect to x1 is p1. And I'm getting that P1 is the derivative of x1. If I know the V, I know the derivative, I can solve it. You tell me x1, I tell you, here I don't need to solve it, this is the inverse demand. The inverse demand, give me x1, let's say 1 unit, then I take the V prime, I substitute instead of x1, 1, and then I know what is my willingness to pay for the 1. And it has nothing to do with M. So if I buy the first one, then I buy the second one, doesn't matter. The second one will be P1 equals V prime of 2, etc., but no income effect. This is the equation of the consumer's ordinary demand for commodity 1. Actually, this equation, if you like to be precise, of the consumer's ordinary inverse demand. Typically, demand is how the quantity depends on the price. But here, how the price depends on the quantity. That's the inverse demand. Ordinary demand curve, this is P1 and X1, okay? So they look at it like this. For this X1, I'm willing to pay this P1. For this one, I'm willing to pay this much. Or you can ask differently. If I want to buy, if let's say I buy X1, okay, what is the P1 that the price that I will be willing to buy X1 units? Okay, so this is actually the consumer surplus. So if the price is P1 prime, and that's a demand, the inverse demand doesn't matter, that's, the curve is the same. And then, so actually, when I say it, since it says, I didn't say curve, so it should be inverse. If it's curve, it doesn't matter. Okay, so the area under the demand is my willingness to pay, but my willingness to pay is all the area under the demand. You see, all these trapezoids, the area here. But I paid P1 times X1. That's my cost. I paid it. So I left with, this is the gain to trade. And since remember, it was that was P1 was equal V prime 1 of X1. Was V1? No, it's called just V. That is the inverse demand. Okay, and let's say that it looks something like straight line, not necessarily straight line. Let's say something like this. And I look on X1. The consumer surplus is, this is the price that I paid. And this area, my willingness to pay is all this area. My willingness to pay is everything. But I pay that much. So the gain to trade is this one. This is the consumer surplus. Just this. Okay? And not this. Good. However, if you want to know, I mean, I want to take what is this area? The area is the integral under this. So actually, this area, the consumer surplus, is the integral from 0 to X1 prime of V prime of X1 dx1. But this is what is the integral of the derivative is the function itself. So this is V prime of, this is V, the function itself, V1, of X1 in between 0 to X1, which is V X1 prime, Vx1 prime minus V of 0. Yeah, that's what I did here is everything. All area. Minus, I have to subtract, the consumer surplus is minus how much I pay. I pay P1 prime, X1 prime. So this is, it's equal to this, let me write it correctly. This is, by the way, the total willingness to pay. So the consumer is willing to pay all this, but he pays that much. So he left with a surplus of this. So this is, as I said, this is actually Vx1, because the integral of the derivative is the function itself, in between 0 to X1 prime, minus P1 prime X1 prime, and this is actually Vx1 prime minus V0 minus P1 x1 both primes. And that's what we're doing. So this is it. And this consumer surplus is exactly the consumer's utility gain from consuming x1 prime units of commodity 1, and under the assumption that we are talking about such a utility function, it doesn't matter, the measure has no problem, because measuring sequentially or simultaneously the way you buy the units will give you the same outcome, because this utility, the property of this utility, that there's no income effect. Consumer surplus is an exact dollar measure of utility gain from consuming commodity 1, when the consumer's utility function is quasi-linear in commodity 2. Okay, x2 is the money, if you like. What it says here, the exact. Before it was approximated. Consumer surplus is an exact dollar measure of utility gain if we are talking about what? Quasi-linear utility function. Quasi-linear in commodity 2, namely commodity 2 is the numeraire or money. Otherwise, consumer surplus is just an approximation. The change to a consumer's total utility due to a change to P1 is approximately the change in her consumer surplus. That's it. So now suppose that I increase, I was at the P1 prime level, and now I increase the price. What happens? So here, this is my demand curve. I don't know why all the time it's a straight line. It's really maybe misleading. Remember, it's not necessarily a straight line. It can be something like this. Okay. So say that at price P1 prime, the demand is x1 prime. That is the consumer surplus. That before any change. What happens if price of P1 will change? The new demand will be something like this, if it will increase. So now say that the price of P1 double prime, okay, increases. So I'm not talking about the demand, I'm talking about specific one price, P1 double prime. So what happens? After that, my willingness, so I'm going to buy less, x1 double prime. And my consumer surplus, my benefit will decrease. Why? Because my willingness to pay for these many units, x1 double prime, is all this area. How much I do pay? P1 double prime times the x1 double prime, all this area. I left with this. Before, I had all this. So I'm losing this. Loss of consumer surplus. P1x1, inverse ordering demand curve. Okay, that's how price depends on x1. How price depends on x1. Remember, it's an inverse ordering demand curve for commodity 1. Now we want to see the difference in consumer surplus. Let's go back here. That's how much we lose if we go from a price P1 prime to P1 double prime. Or if you like, instead of purchasing x1 prime units, I purchase less x1 double prime units, which is supported by, which is demanded at this price. So now we go to, suppose x1 star of P1, okay, that's the demand, the consumer's order and demand curve for commodity 1. The difference in consumer surplus, if I move from P1 prime to P1 double prime, is to take the area, let's say I move from here to here, but remember, I do it now opposite, okay? I look on, don't be misled, Here, I now invert everything. That was inverse demand. Now I do it that the price is here and the quantity is here. So let's say that I look now on the demand curve. So x1 depends on the price, not like here. Here, price depends on x1. So I invert it. Okay, you just invert, and then going from here to here, I have to look on. I have to take the area. So this is now the demand, not the inverse demand, the demand. And I move from P1 to prime to P1 double prime. The area, then the consumer surplus under P1 prime, okay? Yeah, the loss, now what is it? This is before the consumer surplus was everything going under. We have to be careful. It used to be like this. Why? Because for the price, how many units I buy here? X1 up to X1 double prime. X1 prime is the most I will buy with the price P1 prime. Okay? But why this is? Because I have to look. It's a little bit. We have to be careful. It is the total area under the demand function from P1 prime to P1 double prime, and it looks like I go from here to here, the area here. But what is my willingness to pay? My willingness to pay, okay, it depends on the units. So if I'm it's a little bit misleading here. One can think of it as this area minus this area, okay? But why, this is as, here x1 is 0. So I'm going from 0, this is x1 prime, and this is x1 double prime. So I'm going from 0 to x1 prime, or from 0 to less, to x1 double prime, and therefore the difference is actually this minus this, but in any event it's this, if I look on it in this way. I suggest not to be confused. I'm perfectly fine with the case where you just measure it with the inverse demand function. Two additional dollar measures of total utility change caused by a price change are compensating variation and equivalent variation. One, I'm not very impressed with the equivalent variation. The compensating variation is important. Actually, it is also important for policy argument. Let's look on it slowly. So what do we do here? I'm going to change the price, okay, of one good. Let's say of the P1. In that case, the demand, okay, will shift inward. But then I have to, again, I will do mu1 over mu2 dividing by P1 over P2, and I will find the optimal one. Okay, so I have the optimal one before it changes, the optimal one after it changes. Now I can say, let's say that I want to compensate my employees, because now since the price went up, they cannot afford what they could afford before. But I want to leave them with the same utility level. Same utility level. How much I should compensate? It doesn't mean that I have to give them the same money so to enable them to buy the previous optimal bundle. I may give them less money to allow them to use and to buy a different bundle, but that bundle will give them the same utility as they had originally. You see, I don't necessarily, because then, let's say there is inflation or something like this, that the one that I will demonstrate here will compensate people by, let's say inflation was 5%, you don't need to give them an increase in money by 5%. You may compensate them by 4%, and that will allow them, by switching, by substituting, buy a different bundle, but they will be as happy with the new different bundle than the original one, as the original one. I'll explain slowly. Let's say P1 rises. Question: what is the least extra income that at the new prices just restores the consumer's original utility level? Maybe I'll give you an example. But first, the compensation, that is called compensation variation. What is it? So this was the original demand. How do you solve the optimal bundle? You look on the original, that is the budget constraint, and this is the quasi-utility, and the budget should tangent to the utility at one point. Let's say this is the point, then x1 prime, x2 prime is the optimal bundle for consumer under the budget constraint, M1. I leave 2 to be fixed, just changing 1. Now, if P1 rises, the new demand will be something like this. Great, that's the new demand. So now under the new demand, I buy this one. But as you can see, my utility level is not as high as before. I'm losing by in terms of happiness, I'm less happy. Okay, that bundle gives me less utility than that bundle. So, you know what, suppose I want to make you as happy as before. Should I compensate? And by the way, what is this one? This one is actually with the same budget constraint, except that the P1 now, P1 prime is now P1 double prime. Okay, we move to P1 double prime. So now look on the exercise that I'll do. In order for me to allow you to buy this one and that one, it is maybe quite costly for me. Okay? Because in order to allow, what do I need to do? We'll see, okay, in a second. In order to allow, because now I look on how much I consume, okay, from X1 and X2, and actually at the price, and I want to, let's say that in order for me, I can ask myself the following: what is M2 that will allow me, okay, to buy P1 double prime X1 prime plus P2 X2 that allow you to buy this one. Okay? Let me say this.